Hello students, welcome to KENE'S Educare, a group of KENE solutions. This is part 8 of lesson number 10, Gravitation. So in part 7, if you all remember, we already started with thrust and pressure and we even completed that, right? Today, like we need to start from pressure and fluids kind of thing, right? So like we are left with few more topics for the lesson which we will be completing soon. Now thrust and pressure, like as I told you, like whenever we are going to discuss about force, mass and weight will come into picture, right? Same way, thrust and pressure is also one of the part of it, okay? So everyone make sure that you all are revising properly now, because like now we are on to part 8 and today we will be completing like most of the parts. So like within one as like there are 22 questions in the lesson, we may require like one part only for the summary and exercise discussion, okay? So we will take that, and like I guess I'll need one more part for explanation. So make sure you keep on revising it. I'm letting you know so that you are well prepared as well, because as I told you, I don't want any one of you to like sit after this. Okay, whenever you are studying gravitation, you should complete it with me, because you are already allocating approx 8 to 10 hours for every lesson, right? So make sure you do it properly, you revise it properly, because then only it is going to remain in your mind and you'll understand the concepts, okay? Because when you read it for the first time, you only understand 20 to 30% of it, but when you read it like again and again, you understand 100% of it once you read it like more than 3 times. So we are revising it so many times, right? So now whenever you're like I ask you to write any answer, you should be able to write it in brief in your own words without being able to watch anywhere, okay? So you don't have to see anywhere or look for any answers anywhere. It should be like that, okay? So I want each one of you to please start revising whatever notes you have taken in your book, and then I'll show you all the slides one by one quickly. I hope everyone have like completed revising the notes. So we have started our discussion like with the lesson starting with gravitation, what exactly gravitation is, right? So here we have the story of how exactly Newton came up with the idea of gravitation. Then we discussed on this activity where we had a stone like which was moving in a circular path. Like if you do the same activity, you'll find out that how the stone is going to move in a circular path with a velocity of constant magnitude, right? Then we discussed on the universal law of gravitation, that is like where it has been stated that force is directly proportional to the product of their masses and inversely proportional to the square of distance between them, right? So I just want you all to please go through the slide as well, and this is one of the important question, right? So you should be knowing this as well. Then we discussed about like Newton, who exactly he was, what kind of you can say research work he was doing, everything in detail, right? After this, we discussed on like what exactly Newton was trying to formulate and how exactly he came up with the laws of motion. If you remember, in the last lesson, we even discussed on the laws of motion, right? Because it was with respect to force and motion itself. So there we have studied all the three laws of motion, right? Then we discussed on this examples like how can we calculate the force which has been exerted by the earth on the moon by using the formula, like by using the given information, right? I hope every one of you are going through it. Then we discussed on the importance of universal law of gravitation. So please go through it as well. Then we discussed on free fall, and here we have the proper explanation for free fall. So I just want y'all to please go through it. I hope you all are going through it, because over here we have the SI units and all which have been given. Now make sure you are going through the basic information that has been provided, and you're not neglecting it, because somehow you will get that as objectives as well. So over there, like, you will have to write it at the end, right? So you need to know that as well. So sorry. So after this, like, here we discussed on, like, after discussing free fall, we discussed on how can we come up with a formula for calculating equation for calculating the acceleration due to gravity, right? I hope you all are going through it. Then we discussed on like how can we calculate the value of g, that is acceleration due to gravity. I hope you all are going through it as well. Then after this we discussed on like motion of object under the influence of gravitational force of the earth. So here we have the three equations which have been given, and I want each one of you to please go through it as well. After this we discussed on this two different examples, two or three examples which have been given. So I want you all to please go through it as well, as these examples are equally important, which are going to help you further to solve the questions given, right? So you need to first go through the given part so that you can understand which formula and how to apply and how to calculate the further thing. So firstly you need to understand the question properly, what has been given, what you need to find out, and what equation or formula you can apply so that you will get it easily. Okay, and whenever you calculate the part, at the end you need to mention the unit for that. Like if you are calculating force, you need to know that we need to add Newton at the end. I hope every one of you are going through this example. Then after this we had one more example where we have calculated the velocity of the object, and the other thing that we calculated is the time taken by the object to reach the highest point, right? So you have to check what different formulas have been used and how exactly it has been done. After this, we discussed on like mass and weight that we discussed. So please go through this slide and then I'll show you the weight part as well. Then we discussed on weight as well. So I want you all to please go through this as well, everyone. Then we discussed on two different examples of calculating the weight. That was after this. So we discussed on weight of an object on moon, and that is going to be like 1 by 6 times that of the earth, right? So you should be doing this very well. After this, we discussed on two different examples. So I want each one of you to please go through it quickly. Then we discussed on thrust and pressure. So I want each one of you to please go through it. So I hope you all have understood both the situations that have been given for explaining thrust and pressure, because this is the easiest thing I guess that we can have, right? So here we have the formula and the SI unit for pressure, as well as patras that they have given. So please be quick with it, everyone. After this, we discussed on this example, so I want you all to please go through it. This is the same thing, it's just that here you have it more clear. After this, now we will be discussing on pressure in fluids. So see, all liquids and gases are fluids, right? And a solid exerts pressure on a surface due to its weight. Now any of the like object around us, whether be it in any state of matter, be it solid, liquid or gas, they are going to exert pressure on a surface, and that is because of their weight. So similarly, fluids have weight and they also exert pressure on the base and walls of the container in which they are enclosed. Now suppose that is the container, like the container that has been shown in the picture. Now because the fluid also has some weight, that weight of the fluid is going to exert pressure on the walls of the container in whatever container they have been enclosed in. Okay, so pressure exerted in any confined mass of fluid is transmitted undiminished in all directions. Okay, what is written? Pressure exerted in any confined mass of fluid, any mass of fluid. Okay, it doesn't matter like the fluid is less or more, in any confined mass of fluid, that is going to get transmitted undiminished in all direction. Okay, So it means at the end we can say that fluids also exert some pressure on the walls of the container in which they are in, right? That is the thing that we can come up with it. Then the next thing that we have is buoyancy to discuss. So have you ever had a swim in pool and felt lighter? Now if you remember our weight, like you will feel that your weight is so less when you are inside a swimming pool. Or have you ever drawn water from a well and felt that the bucket of the water is heavier when it is out of the water? So when till the time it is inside the water, you'll feel that it's light in weight, but as soon as you like take that bucket out of the water, you'll feel that the bucket is so heavy, right? So have you ever wondered why a ship made up of iron and still does not sink in seawater, but while the same amount of iron and steel in the form of a sheet would sink? So the ship is not sinking, but still, like if you make any other object float on that, it will sink. So this question can be answered by taking buoyancy in consideration, and we are going to understand buoyancy in detail through an activity. But make sure whatever examples that they have asked, like swimming in a pool, then drawing water from a well, and then ship floating on the water and not sinking inside. These are all examples of buoyancy, and we are going to discuss buoyancy in detail through this activity. So what we need to do is take an empty plastic bottle, close the mouth of the bottle with an airtight stopper. What we will do, we are going to close the mouth of the bottle with the airtight stopper and put it in a bucket which is filled with water. Then you see that the bottle floats. Okay, what will happen? The bottle will float. Now push the bottle into water again and you will feel an upward push. What you will feel? You will feel an upward push. So try to push it further down. Like you need to take the bottle and you need to like exert some pressure and you need to put it further down. And you will find that it is difficult to push deeper and deeper. So this indicates that water exerts a force on the bottle in the upward direction. What does it indicate? That water exerts a force on the bottle in the upward direction. So the upward force exerted by the water will go on increasing as the bottle is pushed deeper till it completely immersed. Okay, so now release the bottle and it bounces back to the surface. So it's all because of the gravitational force again, like it is all because of buoyancy, you can say, right? So does the force due to gravitational attraction of the earth act on this bottle? And if so, why doesn't the bottle stay immersed in the water if it is released? And how can we immerse the bottle in water? So you have to answer me all the questions that have been asked over here. I hope every one of you are going through it and you're trying to answer the concept on buoyancy. See, what explanation you can give over here is the gravitational attraction of the earth acts on the bottle in a vertically downward direction. So when the bottle is released, the bottle experiences an upward force, which we call it as upthrust, or we can even call it as buoyant force. Got it? What do we call that force as? Upthrust, or we can call it as buoyant force. So the upward force exerted by a liquid on a body that is immersed in the liquid is known as the upthrust or buoyant force. Like how, if you have to define it, how would you define it? The upward force exerted by a liquid on a body that is immersed in the liquid is known as upthrust or buoyant force. Okay, so the bottle displaces water of volume which is equal to its own volume. That is the reason that the bottle starts floating, because of the weight which is displaced. Okay, and when the bottle is released, it does not stay immersed in the water, because at this time the buoyant force exerted by the liquid will be more than the weight of the object. Getting it? What will happen? The buoyant force which will be exerted by the liquid will be more than the weight of the object, and we can immerse the bottle in water by filling it with water. Then what will happen? Its weight will be more than the upthrust and it will sink. So what conclusion we can come up over here is like the relation between the weight of the object and the upthrust is responsible for the floating of the object. What is responsible? The weight of the object and the buoyancy, which we also call it as upthrust. They both are responsible for floating of the object, be it any object. Okay. So I hope you all are writing about buoyancy in detail. Whatever I told you, you need to write that. So now, like after this, we have buoyancy, which has been discussed over here. See, this is the same thing that I told you all, okay? The force due to the gravitational attraction of the earth acts on the bottle in the downward direction. Okay, what happens? The bottle goes like in the downward direction. So the bottle is pulled downwards, but the water exerts an upward force on the bottle. What happens over here? The bottle exerts an upward force on the bottle, and thus the bottle is pushed upward. Getting it? Why the bottle has been pushed upward after that? Because the water exerts an upward force on the bottle. So we have learned that weight of an object is the force due to gravitational attraction of the earth. What is weight of an object? It is the force due to gravitational attraction of the earth, and when the bottle is immersed, the upward force exerted by the water on the bottle will be greater than its weight. What they have stated, when the bottle will be immersed, the upward force that is already exerted by the water on the bottle is going to be greater than its weight, because of which it will rise up when released. Like, I will suggest you all to do the activity so that you know it, like why the water is going downward and why it is coming upward. Okay. So to keep the bottle completely immersed, the upward force on the bottle due to water must be balanced, and we can achieve that by an externally applied force acting downward. How can we achieve that? By an externally applied force that is acting downward, and this force must at least be equal to difference between the upward force and the weight of the bottle. What it should be equal to? Difference between the upward force and the weight of the bottle, and the upward force which has been exerted by the water is known as upthrust or Bion force. So you have the definition given over here. The upward force exerted by the water on the bottle is known as upthrust or Bion force, and in fact all objects experience a force of buoyancy when immersed in a fluid. So the magnitude of this Bion force is going to depend on the density of the fluid. What it is going to depend on? It depends upon the density of the fluid. Okay. I want you all to please write all the important points from here. Now after this, in the next class, I'm going to start with why objects float or sink when placed on the surface of water. This is one of the part that we will be discussing. Then after that, we have activity 10.6. We have Archimedes principle to discuss in detail. So we'll be discussing that through an example and who exactly Archimedes was. Then after Archimedes principle, we will discuss on relative density in detail. Okay, then after relative density we have few examples that we will be discussing on, and then we have the summary discussion. So mostly like next part I'll complete with the lesson, and one more part I'll need for completing the exercise questions, because you all know that there are 22 exercise questions that we need to discuss, right? So I'm going to show you all the exercise question. I want each one of you to please go through them properly. So this will be the last question that we will be discussing on, and this is how we will be ending up with the lesson gravitation. So make sure you keep on revising each and everything that we are like adding on each and every session. Okay, I'm ending this part over here, but make sure as discussed, keep on revising each and everything and try to write the answers in your own words as well. Now, like take any concept, like let's say write a note on universal law of gravitation in your own words. Write about thrust and pressure in your own words. Like you can take the concepts and you can start writing their answers in your own words and check whether you're aware of the concept properly or not. Okay, so I'll start with the rest of the part for the lesson in the next class. Thank you everyone.